Welcome to math classes. Today we'll continue the limit continuity and differentiability chapter. Okay, in the first video we have already covered limit and continuity. So we'll cover the differentiability, and just for information, this is NCERT class 12th chapter 5. Okay, so what we are going to cover in this is differentiability, then exercise 5.2, implicit differentiation. Okay, differentiation of inverse trigonometric functions, then exercise, differentiation of exponential logarithms, exercise, okay, parametric form, then some more exercise, and then second order differentiation, okay, and exercise 5.7 and miscellaneous exercise. So with this, we will completely do the all the concepts of differentiation and differentiability. Okay, limits, differentiation, and differentiability. All the concepts will be complete, which will be helpful for you in not only maths, in physics and chemistry also. Okay, that's why just I'm taking class 12th chapter also just to complete it. Okay, so let's get into this. The concept is very simple. We have already learned limit continuity. Okay, so similarly, differentiability also, it's a condition to check whether a given a function is differentiable or not. Okay, how do you check that? Let's first check the derivation. Simple definition. Derivation is a small change in f of x with respect to change in parameter x. Okay, so f dash x is defined as limit h tends to 0, f of x plus h minus f of x by h. Okay, so this is my derivation definition. If this is my definition, then what is differentiability? Differentiability is to check whether a given function is differentiable or not. Okay, we will learn more about it in the next slide. Okay, right now let's see, just brush up all the concepts which we learned in derivations. Okay, so what are the algebra of derivatives? If u and v are two different functions of x, then differentiation of u plus or minus v is nothing but differentiation of u with respect to x, and plus or minus differentiation of v plus or minus with respect to x. Okay, so this is same like algebra. Okay, a plus b equal to uh, a plus b basically. Okay, so differentiation of, next is differentiation of multiplication of two functions, which is u and v. Differentiation of u and v is equal to u dash v plus u v dash. Okay, you will sum up doing the individual function differentiation and product with the others. Okay, differentiation of u by v, okay, is equal to u dash v minus u v dash divided by v square, and this is provided v is not equal to 0. Okay, that is one condition. Okay, next, the chain rule. This is most important, which we have done some problems in the initial videos, okay, chapters, but understand this completely. Okay, chain rule is nothing but if y is defined as h of t and t is defined as g of x, okay, then y dash, okay, y dash will become h dash t then g dash x into, basically. Okay, because t is nothing but g of x, right? So you will differentiate it separately. First you will treat h of t as a function of t and then differentiate with respect to t, and then you take the t, which is nothing but g of x, and differentiate it again, and this is the product of those outcome. Okay, so this is first differentiate the outer function first, okay, then differentiate the inner function. Okay, example, y equal to sine of x square. Okay, so I will consider sine of x square as sine t. Okay, then y dash is nothing but cos t. Cos t is cos x square, correct? Then you take x square and differentiate again, which is 2x. Okay, so if this x square instead of x square, if it is a complex function which involves more f of x, g of x, or such functions, then you continue doing this. Okay, like a chain. That is what we are trying to tell. Okay, so this is very important one. I think most of the first chapter exercises we will do using this chain rule. Okay, so differentiation, since it is a new concept for class 11th and class 12th students, you need to do more problems starting from easy problems to the toughest ones. Okay, so you have to do NCERT book for this one, and it may take very small time once you start doing it actually, but you have to completely do it to cover all types of problems. Okay, so now let's understand the differentiability. Okay, just like limit continuity, you have LHL and RHL, right? Left hand limit and right hand limit, which should be equal, and that should be equal to f of 0. Similarly, for differentiability, you have left hand derivative and right hand derivative, and both should be finite and equal. Only then derivative at that point is defined, differentiation is defined. Okay, or we can call it, the function is differentiable at that point. Okay, so for every function to be differentiable in the range a comma b, then the function should be first condition is it should be continuous in that range. Okay, limit should be continuous in that range. Okay, this is most important. Most of us will miss this point actually. We'll directly go and differentiate, but if continuous, if it is not continuous, then there is no point to differentiating. Okay, at that point. Then left hand right hand derivatives of that function at every point should be finite and equal. Okay, what is right hand derivation? Okay, at x equal to c is limit h tends to 0 plus 0 plus, okay, f of c plus h minus f of c by h. Okay, same as derivation definition. If you see, only thing is here h tends to 0 plus. Okay, and similarly LHD is nothing but h tends to 0 minus. Okay, c of f of c plus h minus f of c divided by h. Okay, now only thing is note down, this is nothing but, okay, if I replace LHD h tends to 0 minus is same as this value. Okay, if I call this 0 minus, then it will become basically 0 minus, right? This is, so it will become f of c minus h minus f of c, f of c minus h minus f of c divided by minus h. Okay, most of the people use this definition. Okay, even though it is not given in NCERT book, but for IIT, whoever is practicing, you use this condition to check. Both are correct actually. This is more often used for IIT practice, JEE practice basically, or JEE or any other entrance exams. Okay, so note down both of them. Both are same actually. If you can take some example and try, both are same. Okay. Now note that every differentiable function is continuous. Okay, means when some function you are saying differentiable, you are already checking continuity. It is continuous. That's why you went ahead and checked the differentiability. Correct. So if some function is differentiable, then it is continuous. Okay, but every continuous function may not be differentiable. Means you check the continuity. It is okay. It is continuous, but still differentiability may not be applicable, or it may not be differentiable at that point. Okay, you will see some examples of such functions, especially where you get this spikes and wherever you get corners in the curve, actually something like absolute x, okay, modulus of x, modulus of all modulus functions, step functions, these are all discontinuous. uh, they are I mean, at least modulus is continuous function but not differentiable. Okay, step function is both discontinuous as well as not differentiable at integer values. Okay, you will see those examples coming anyway. Okay, so let's do exercise 5.2. 5.1 is already covered in limits and continuity in the previous video. Okay, so this is 5.2. Okay, differentiate the function with respect to x, f of x equal to sine of x square plus 5. Okay, so this is what the chain rule I am talking about. You will practice more problems with the chain rule here actually. Okay, so first is we'll assume it is sine of t, correct? So f dash x is nothing but cos of t, which is t is nothing but x square plus 5, and then differentiate x square plus 5. Okay, if I differentiate x square plus 5, this is nothing but 2x. So cos of x square plus 5 into multiplied with 2x, which is 2x cos x square plus 5. Okay, then cos of sin x, same way you will do. Okay, first is f dash x is cos differentiation is minus sine. Okay, so minus sine of sin x, then differentiation of sin x, which is cos x. So minus cos of, sorry, this is wrong actually. Oh, sorry, correct. Uh, Sin x differentiation is cos x. So minus of cos x into sine of sin x. Sine of sin x is here. So sine of sin x and cos x, this differentiation is cos x, minus sine is here. Okay, next. Sine of ax plus b, same way you can do it yourself. Okay, differentiation of sine is cos, and then differentiation of ax plus b is a. So a cos ax plus b. Okay. Secant of uh, tan of square root of x. Okay, this is 3 times basically. Chain rule will apply 3 times. Okay, so let's do one problem at least. First is secant of t. Okay, secant x differentiation is secant x into tan x. Correct. So x is nothing but tan square root of x. So I'll keep it same. So secant of t into tan of t, then differentiation of t. Correct, which is tan of square root of x. Okay, now I wrote these values as is. Then differentiation of tan x or tan theta is nothing but secant square theta. So I wrote it here, and theta differentiation, that is square root of x differentiation, which is nothing but 1 by 2 square root of 1 by 2 square root of x. Okay, so this is nothing but overall, write carefully, secant of tan square root of x, tan of tan square root of x, secant square of square root of x divided by 2 square root of x. Okay, so this is, we are doing applying chain rule 3 times. Okay, so you can do as many times as until you get differentiation of x which is 1. There we will stop basically. Okay, differentiate with respect to x for this function. Okay, sine by cos, you assume that this is in u by v ratio. Okay, and do it normally and then apply the chain rule. Okay, if I apply a u by v ratio, this will become sine differentiation is cos of ax plus b, and then cos of cx plus d into differentiation of ax plus b is nothing but a. Then it is minus actually, right? Minus, but minus comes from the differentiation. Okay, now sine of ax plus b, I wrote it as is. Cos cx plus d differentiation is minus sine cx plus d. So minus into minus has become plus. Then cx plus d differentiation, which is c. Then denominator I have cos square cx plus d. Okay, so carefully do it. This is chain rule. Applying chain rule is very easy once you get used to it. Solve problems. These problems you solve it, you will get used to it, and you don't need to do in 2-3 steps. You can write it in 1 step directly actually. Okay. Okay. Cos x cube into sine square x power 5. Okay, same way we will apply chain rule as well as uv, product differentiation of product of functions. Okay, so u dash v plus uv dash. Okay, or you can do whatever you want. Okay, so first is cos x cube is minus sine x cube into x cube differentiation is 3x square into sine square x to the power of 5 or sine x to the power of 5 whole square, as is I kept it. Okay, now next is cos x cube, I keep it here. Then differentiation of this one is nothing but 2 into sine x to the power of 5. Okay, and sine x to the power of 5 differentiation is cos x to the power of 5. Okay, then x to the power of 5 differentiation is 5x to the power of 4. Now if I summarize this one, okay, this is nothing but if I take x square sine x to the power of 5 common, this will become 10x square cos x cube cos x to the power of 5. Okay, that is from here. Okay, minus 3 sine x cube into sine x to the power of 5 from here. Okay, next, differentiate with respect to x, f of x equal to 2 square root of cot x square. Again, you will apply chain rule here. Okay, so this you assume 2 square root of x and then do it. Okay, which is nothing but 2 cot x square whole to the power of 1 by 2. So which is nothing but 1 by 2 into 2 as is I wrote 1 by 2 into cot x square into 1 by 2 minus 1, which is minus 1 by 2. Then differentiation of cot x square. Okay, so differentiation of cot x square is nothing but minus cosec x square and the differentiation of x square, which is 2x. So if I summarize this is what the this is what the answer. Okay, 2x cosecant x square divided by square root of cot x. Okay, square root of cot x, the new denominator came from this one, right? Minus half pieces. Okay, next, f of x equal to cos of square root of x. I think you can do it very simple. Okay, next, prove that the function f of x equal to modulus of x minus 1 where x belongs to R is not differentiable to x equal to 1. Okay, we know that modulus functions are not differentiable. Why? Because they come with a sharp edges, correct? So if you see modulus of x minus 1 is in the form of like a V shape, and at the peak, okay, bottom is x equal to 1. At x equal to 1, it will take a the edge will form basically. So at the place of edge, any edges in the graph are not differentiable basically. Okay, but if you see modulus of x minus 1 is continuous. It is a continuous function. Without lifting your hand, you can actually draw the line, correct? So let's see how to do this. Okay, so first let us define the function clearly. F of x is nothing but, okay, minus x plus 1 if x is less than or equal to 1, correct? If x is less than or equal to 1, this will become minus because you will get a negative value, so I have to apply minus. So minus of x plus 1, and this is equal to x minus 1 if x is greater than 1. Now at x equal to 1, f of x is absolute modulus of x minus 1, which is continuous. Okay, so f of 1 equal to 0. If I substitute 1, okay, I'll get 0, right? Both 0. So LHL equal to RHL equal to f of 1 equal to 0. Now let's check the left hand derivative, LHD, which is nothing but limit of x tends to 1 minus f of x minus f of 1 divided by x minus 1. Okay, which is nothing but f of x when it is 1 minus when it is 1 minus less than 1, it is nothing but this definition. So minus x minus of x minus 1, basically I just took the minus common, okay, minus of x minus 1, okay, minus f of 1 divided by x minus 1. Okay, now we know that f of 1 is 0, okay. So if I substitute that, this will become minus 1, okay. This is 0, right? Then this is minus of x minus 1, this is x minus 1, so you'll get minus 1. Similarly, RHD is nothing but limit x tends to 1 plus f of x minus f of 1 divided by x minus 1, which is equal to limit x tends to 1 plus, this is 1 plus. So if it is 1 plus, the definition of f of x is this one, x minus 1. So x minus 1 minus f of 1 divided by x minus 1, we know this is 0. So x minus 1 divided by x minus 1, which is 1. So LHD is minus 1, RHD is 1. So they are not equal. So it is not differentiable at x equal to 1. Okay. So this is how you will check the point of differentiability. Okay. Next. Prove that the function f of x equal to step of x, okay, where x is between 0 and 3 is not differentiable at x equal to 1 and 2. So clearly this is a step function, it is not even continuous actually at integral values. We have to just prove that it is not differentiable, okay. So what are the values we should consider is between 0 and 3 there are two integer values, which is 1 and 2, okay. So he is asking us to check both at x and x equal to 1 and x equal to 2, what is the outcome. And definitely they are not differentiable, we know it, right. So first define the function f of x equal to step of x, or GIF of x we call it, okay, greatest integer function. So this is equal to 0 if x is between 0 and 1, correct, less than 1, x is less than 1, so it will be always 0. It is equal to 1 if it is between x 1 less than or equal to x and less than 2. This is less than 2, it is not equal, so this will always be 1. And it is equal to 2 if it is x is between 2 and 3, okay. So now this is how the function is defined. Now at x equal to 1, we know f of 1 equal to 1, step of 1, so which is 1. Now LHD is nothing but limit of x tends to 1 minus f of x minus f of 1 divided by x minus 1. If it is 1 minus, I have to consider this as 0 actually, correct. Step of x is nothing but 0, okay. So in other ways I can write it like this, LHD equal to limit h tends to 0 minus, because if h is equal to x minus 1, as x tends to 1 minus, h tends to 0 minus, correct. So same way we can actually use this also, this will be 0 by definition, okay, minus f of 1, which is 1, divided by x minus 1. So if x is tending to 1 minus, this will be 0, correct. So this is nothing but 1 by 0 form, okay. This is nothing but 1 by 0 form, which means it does not exist. LHD does not exist, which means it is not differentiable at x equal to 1. Okay. Similarly, at x equal to 2, same thing you can do. Actually, you will get again 1 by 0 form. So f of x is not differentiable at x equal to 2. Okay. Alternatively, how do you want to solve this problem? Very simple. We know differentiability first condition is continuity. Correct. So you can also prove that at x equal to 1 and x equal to 2, this function is not continuous. Hence, it is not differentiable also. Okay. So that way also you can solve this problem. Whichever is simple, since we are in the differentiation chapter, I just use differentiation to solve this. But right way is first condition you should check first. So continuity you can actually solve this. Yeah. Next. Yeah. Now let's understand the implicit differentiation. Okay. Implicit differentiation is very simple. If we call if a function y is defined as f of x, okay, which means there is only LHL side you have y, and then RHL side whatever is expression is in terms of x. Okay, this is called explicit function. Y is clearly expressed in terms of x. If a function is something like this, y plus sine y equal to 3x square. Now y is not clearly defined. Even if I say y equal to 3x square minus sine y, you have y on the LHL side also, right? Left hand side also, which means this is called an implicit function. Okay. Now for differentiation of such functions, treat y as a function of x and use the chain rule to solve. Okay. How do you this? Just take an example. Y plus sine y equal to 3x square. So dy by dx, this one differentiation with respect to x. Then sine y is nothing but cos y into y differentiation is dy by dx. This is sorry. Okay, dy by dx, which is equal to differentiation of this one is 6x. Now you take all dy by dx common, okay, which is if I take common, it will become 1 plus cos y equal to 6x. So dy by dx is nothing but 6x by 1 plus cos y. So this is how you solve the implicit differentiation functions. Okay, let's take another example. Sine of xy plus y equal to 0. So sine of xy differentiation is cos xy. and then you differentiate xy with respect to x, which is nothing but y plus x into dy by dx plus differentiation of y is dy by dx, which is equal to 0. Now you take all dy by dx common, and then which is equal to minus of y cos xy divided by x cos xy plus 1. Okay, so this is the one method of one way of differentiation. You should understand. This is also very common in the problems. Just like chain rule, this is also very common. Okay. Now differentiation of inverse trigonometric functions, we actually take help of uh, the previous one, implicit differentiation. Okay, we take help of implicit differentiation to solve actually the inverse trigonometric function differentiation. Okay, so how? Let's say y equal to sine inverse of x here. Okay, y equal to sine inverse of x. Then we use implicit differentiation and chain rule. How do we do this? Y equal to sine inverse of x. So sine y equal to x. Correct. Now you differentiate this one. This is nothing but cos y into dy by dx, which is equal to 1. Okay. Now dy by dx is nothing but 1 by cos y. Okay. Now we know that sine y equal to x. So cos y is nothing but square root of 1 minus x square. Okay. Because sine square x plus cos square x equal to 1. So cos y is equal to square root of 1 minus x square. So dy by dx is nothing but 1 by square root of 1 minus x square. Okay. Similarly, you will get cos inverse x differentiation is minus 1 by square root of 1 minus x square. Okay. And then, yeah, tan inverse you can see here. Same way you can solve actually. Y equal to tan inverse of x, tan y equal to x. So secant square y dy by dx equal to 1. Okay, tan y equal to x. So secant y is nothing but square root of 1 plus x square. So secant square y is nothing but 1 plus x square. So dy by dx is 1 by 1 plus x square, where y is tan inverse of x. So this is how inverse trigonometric function derivations you can get. Okay, this is also important. Inverse trigonometric differentiations are very common in the questions. Okay, let's do exercise 5.3. Use these rules basically. Okay, find dy by dx of 2x plus 3y equal to sin x. So as we said, if we differentiate directly, it will become 2 plus 3 dy by dx equal to cos x. Okay, 2 plus 3 dy by dx equal to cos x. Dy by dx is nothing but cos x minus 2 divided by 3. Okay, this is also same. Okay, so dy by dx will get 2 divided by cos y minus 3. Okay, this is also straightforward. Ax plus by square equal to cos y. So if you differentiate, ax is a, by square is nothing but 2b y into dy by dx equal to minus sin y into dy by dx. So if I take all dy by dx terms one side, I'll get dy by dx equal to minus a by sin y plus 2by. Xy plus y square equal to tan x plus y. Same, you will do same way. Okay, you have to apply all the rules. Xy, when you differentiate, you will apply uv rule. This is x to the power of n rule, tan x, and then y. Okay, so this is nothing but y plus x dy by dx. This is nothing but 2y dy by dx, secant square x dy by dx. Now take dy by dx terms one side, and you will get secant square x minus y divided by x plus 2y minus 1. Okay, same, x square plus xy plus y square equal to 100. Same way you will do. Okay, then x cube plus x square y plus xy square plus y cube equal to 81. Same way you will do. Okay, you have to solve this all these problems yourself actually. Just check. If you go wrong, you check this video. Okay, this is the right way of doing these problems. Okay, sin square y plus cos xy equal to pi. Okay, so this one is, let's do this. Sin square y is nothing but 2 sin y into cos y into dy by dx, because y is in the form of x. Okay, cos xy is nothing but minus sin xy into xy differentiation is y plus x into dy by dx, which is equal to 0 because differentiation of pi is 0, constant. Now you take dy by dx terms one side, okay, which is equal to dy by dx equal to y sin xy divided by sin 2y minus x sin xy. Okay, next, same way, sin square x plus cos square y equal to 1. Okay, so you differentiate, you will get 2 sin x cos x minus 2 cos y sin y. Okay, dy by dx equal to 0. I can call this one as sin 2x. This one is sin 2y. Okay, so sin 2y into dy by dx equal to sin 2x. So dy by dx equal to sin 2x by sin 2y. Okay, and the other way of doing this one is sin square x plus cos square y equal to 1 means x equal to y. Correct, which we know. If x equal to y, dy by dx equal to 1. Okay, if you substitute x equal to y, this is also 1. Correct? So you can cross check your answer. Okay, next. Okay, y equal to sine inverse of 2x by 1 plus x square. This is an interesting problem. You can actually solve it taking sine to the other side and solve it, or if you remember the sine derivation, that is 1 by square root of 1 plus x square, you can actually do and then do apply chain rule, because x is nothing but 2x by 1 plus x square. Okay, it easier way is, okay, whenever you see this 2x by 1 plus x square in trigonometric form, okay, something should strike to you. Okay, 2x by 1 plus x square, if x equal to tan theta, this is nothing but sine 2 theta. This is sine 2 theta definition in terms of trigonometry. Okay, so if x is tan theta, so let's take x equal to tan theta, then 2x by 1 plus x square is nothing but 2 tan theta by 1 plus tan square theta, and that is nothing but sine 2 theta. Okay, so my y is nothing but sine inverse of this value, right? Okay, so sine y equal to tan this value, which is nothing but sine 2 theta. Okay, so this means y equal to 2 theta. Theta is nothing but tan inverse of x. Okay, so y equal to 2 tan inverse of x. So my dy by dx is nothing but 2 by 1 plus x square. So easy to solve it. Okay, you can also do other way, but this is easy. You apply, use your trigonometric knowledge, apply it here, then you will get easily the differentiation. Okay, same thing here. Okay, if you see this 3x minus x cube by 1 minus 3x square, it should strike to you, this is tan 3 theta. If x is tan theta, this is tan 3 theta. Okay, then this y is nothing but 3 theta. Theta is nothing but tan theta, tan x. Correct? Theta is nothing but tan inverse of x. So you'll just get the answer straightforward. Okay, so tan y is this value. Let x equal to tan theta. This is nothing but tan 3 theta. So y equal to 3 theta or 3 tan inverse of x. So dy by dx equal to 3 by 1 plus x square. Okay, so this is how we should solve this trigonometric derivations. You can apply all your knowledge in uh, other areas, okay, into differentiation. Simplify first the expression, you should simplify and then apply differentiation. That is the easy way. Okay, next. Find the differentiation if y equal to cos inverse of 1 minus x square divided by 1 plus x square. Okay, so this is also similar to the before one. You should understand what is 1 minus x square by 1 plus x square. Okay, if you take x as tan theta, 1 minus tan square theta by 1 plus tan square theta is nothing but cos 2 theta definition. Okay, so once you know this, this is very simple. Now this will become cos inverse of cos 2 theta, which means y equal to 2 theta. Y equal to 2 theta means it is nothing but y equal to 2 tan inverse of x, which is nothing but differentiation is 2 by 1 plus x square. Okay, now again, okay, dy by dx if y equal to sine inverse of this one. Okay, it is same exactly, instead of cos inverse it is sine inverse. So you will get here cos 2 theta. Okay, if you take x as tan theta, if you take, you get cos 2 theta. Okay, so sine y equal to cos 2 theta. But now you cannot cancel, right? What is y equal to cos 2 theta? Again, just think about trigonometric formula. Cos 2 theta you can write it as sine of pi by 2 minus 2 theta. Correct? Now both sides is sine, and so angle should be equal. So y equal to pi by 2 minus 2 theta. Okay, so differentiation, which is theta is nothing but tan inverse of x. So it is nothing but pi by 2 minus 2 tan inverse of x. dy by dx is equal to minus 2 divided by 1 plus x square. Minus 2 into tan inverse differentiation, which is 1 by 1 plus x square. So the answer is dy by dx equal to minus 2 by 1 plus x square. Okay, so you need to use lot of tricks and trades of trigonometry to solve these problems actually. Okay, otherwise you can still do it. Go ahead and apply chain rule, you can do it, but it will be a little bit complex. If you don't do any mistakes, I think you will get same answer from there also. Okay, next, y equal to cos inverse of 2x by 1 plus x square. Okay, so 2x by 1 plus x square, we know if x is tan theta, this will become sine 2 theta. Correct? If x is tan theta, 2x by 1 plus x square is sine 2 theta. So this will become cos y equal to sine 2 theta. Cos y equal to sine 2 theta. Sine 2 theta I will write it as cos of pi by 2 minus 2 theta. So y is equal to pi by 2 minus 2 theta, or pi by 2 minus 2 tan inverse x. dy by dx is nothing but minus 2 by 1 plus x square. Only differentiation of tan inverse of x I will do. That's all. Okay. Next. Again, dy by dx equal to sine inverse of 2x square root of 1 minus x square. Okay, now if you see it, okay, if you see 2 Sin theta into square root of 1 minus x square is cos theta, correct? 2 sin theta cos theta is nothing but sin 2 theta, correct? So let's assume x equal to sin theta, okay? X equal to sin theta, then 2x square root of 1 minus x square is nothing but 2 sin theta square root of 1 minus sin square theta, which is cos theta. So this is nothing but 2 sin theta cos theta, which is sin 2 theta, okay? So y is equal to sin inverse of this value, which is nothing but sin y equal to sin 2 theta. So y is equal to 2 theta, which means y is equal to 2 sin inverse of x, 2 sin inverse of x, okay, which means dy by dx equal to 2 by 2 divided by square root of 1 minus x square, okay? So this big expression is as good as y equal to 2 sin inverse of x. See how simple. If you really if you are good at trigonometric equations, you should be able to solve these problems very easily. Next. Okay, y equal to secant inverse of 1 minus 2x square minus 1. Now you think about what you can apply here. Okay, if x is cos theta, x is cos theta, then 2 cos square theta minus 1 is 2 cos square theta minus 1 is cos 2 theta. 1 by cos 2 theta is secant 2 theta. So this is nothing but secant 2 theta. Correct? So let's do same. X equal to cos theta. 1 minus 2 x square minus 1 is secant 2 theta. Okay. So secant y equal to secant 2 theta or y equal to 2 theta or y equal to 2 cos inverse of x. So dy by dx equal to minus 2 divided by square root of 1 minus x square. This is the answer. Okay. Yeah. Let's now learn very quickly what is the differentiation of exponential and logarithmic functions. Okay. So this is one tricky thing is understanding how to derive these things is one of this you should know actually, either differentiation of log x or differentiation of exponential. Okay. Once you know this, deriving the other one is easy. So we have already learned differentiation of log x equal to 1 by x. Log x means log base e. Okay. So from that we will derive differentiation of e to the power of x. Okay. So y equal to e to the power of x, dy by dx equal to same value e to the power of x. Okay. Y equal to a to the power of x, then dy by dx equal to a to the power of x into log a. Okay. Now how to derive this? Okay. Let's do it here. Y equal to log x, right? If y equal to e to the power of x, y equal to e to the power of x, um, you can call it x equal to log y. Okay, and then once you know x equal to log y differentiation is 1 by y dy by dx, so that is nothing but e to the power of x. Okay, so y equal to log x, we know that this is 1 by x. Okay, if you know one of them, deriving the other one is easy. Okay, and y equal to log x base a, then you can write it as log, that is base e to the log x to the base e, log a to the base e. Okay, you can write it as, right? So once you know this is a constant. So only thing is I am applying a differentiation here, which is 1 by x. So 1 by x into log a. This is the differentiation of log x to the base a. Okay. So remember these four. These are very useful. Let's do one example here. Let's say y equal to square root of x minus 3 into x square plus 4. Okay. Divided by 3x square plus 4x plus 5. Then how to do differentiation of this one? This is very complex if you really apply chain rule and u by v rule, all that, right? It is very complex. So take logarithm. Okay, once you take logarithm, the advantage is logarithm will convert products into addition, division into subtraction. Okay, so log y equal to log of this whole expression, which is nothing but 1 by 2 into log of square root I have removed. Okay, this one. Now this is nothing but log y equal to half of log x minus 3 plus log x square plus 4 minus log of 3x square plus 4x plus 5. Okay, now you do differentiation. This is very easy. 1 by y dy by dx, which is equal to half into differentiation of this one is 1 by x minus 3. Then this is 1 by x square plus 4 and the differentiation of x square, which is 2x. So 2x by x square plus 4. This is 1 by 3x square plus 4x plus 5 and differentiation of this one, which is 6x plus 4. Okay. So you simplify it, this is what you will get, 1 by 2 log of square root of this value and this. Okay. So this is the advantage of using logarithms and exponential in differentiation. You can convert some complex equations into easy additions and subtractions. Okay, let's do some exercise now. Okay, so exercise 5.4. dy by dx of e to the power of x by sin x, which is u by v form you will apply, correct? So differentiation of e to the power of x is e to the power of x, sin x is cos x. Okay. So u by v, if you apply, it will become e to the division is denominator is sin square x, and here it is e to the power of x into sin x minus e to the power of x into cos x. Okay. Next, e to the power of sin inverse of x. You can apply chain rule. Okay, dy by dx equal to e to the power of sin inverse of x, and the differentiation of sin inverse of x is 1 by square root of 1 minus x square. Same thing. First you do e to the power of x cube is e to the power of x cube, then differentiation of x cube, which is 3x square. So it is nothing but 3x square into e to the power of x to the power of 3. Okay. Sine of tan inverse of e to the power of minus x. Okay, which is again you do sine. First differentiation of sine, which is cos of tan inverse of e to the power of minus x. Then tan inverse differentiation, which is 1 by 1 plus x square. X is nothing but e to the power of minus x here. So e to the power of minus 2x. Then e to the power of minus x differentiation, which is minus e to the power of minus x. So you simplify it. This is what is the answer. Okay. Next, log of cos of e to the power of x. Again, you will apply chain rule. You can do it yourself. This is the answer. Minus e to the power of x tan of e to the power of x. Okay. Then this is you can apply u plus v rule. Basically, differentiate each term individually. So you will get e to the power of x plus 2x e to the power of x square plus 3x square into e to the power of x cube up to 5x to the power of 4 e to the power of x power 5. Okay. This is also you can apply chain rule. First assume it is square root of x. So it will be 1 by 2 into 1 by 2 into square root of x, and then apply differentiation of e to the power of square root of x, which is e to the power of square root of x into square root of x differentiation, which is 1 by 2, again 1 by 2 root x. Okay, so overall this is the answer. Do it carefully, don't do mistake. That's all. Log of log x. So we know log x is 1 by x. So log of log x is 1 by log x, and log x differentiation, which is 1 by x. So 1 by x log x. Okay. Next, cos x by log x, you can apply u by v rule. Very simple. Okay. Then dy by dx of cos of log x plus e to the power of x, you can apply chain rule. Cos x is minus sine of log x plus e to the power of x, and then differentiation of this one, which is 1 by x plus e to the power of x. So this is the answer here. Okay. Let's do exercise 5.5. More problems. Yeah, dy by dx of cos x into cos 2x into cos 3x. Okay, you can do this way actually. You assume that cos x is one function f of x and cos 2x into cos 3x is g of x. Okay, and then you can separately do g of x differentiation and then combine with this one. Okay, so as a thumb rule, okay, for product instead of uv, if I extend it to uv, w, x, y, z, whatever actually, okay, how many number of product of functions here, okay, we can easily prove that this is differentiation of this one is equal to u dash vw plus u v dash w plus u v w dash. Okay, if there are four functions, you will get one more addition actually. Okay, four times you will get, and each time you will do differentiation of one of the function and others are in the product. Okay, we will prove the same thing in this video, this formula actually. Okay, so you can apply this formula and then solve it easily. Y equal to cos x into cos 2x into cos 3x. So y dash is minus sin x into cos 2x cos 3x as is, then minus 2 cos x into cos 2x differentiation is minus sin x, so minus s come here actually 2x, and 2x differentiation is 2 into cos 3x, then minus, okay, cos x cos 2x as is, and cos 3x differentiation is minus sin 3x and 3. Okay, so this is how you can do differentiation of this one. Okay, u v w or whatever number of functions are there in product. Okay, next. Yeah, this we know that we can easily do it by logarithm. Okay, so you consider y as log y equal to log of this value, and this is nothing but square root will come in the front. Okay, half into log of x minus 1 into x minus 2 into divided by x minus 3 into x minus 4 into x minus 5. So you can write this as this summation and subtraction. Okay, denominator all values are in subtraction. Okay, numerator are in addition. Okay, so log of x minus 1 plus log of x minus 2, and then these are subtraction. Now you do differentiation individually, and then this is the result you will get. Okay, y is here, y is nothing but this value, right? So y is here. Okay, next, log x to the power of cos x. So whenever you see power actually, f of x to the power of g of x. Okay, you don't get confused by x to the power of n. Okay, the differentiation of x to the power of n is n into x to the power of n minus 1, but that is not the differentiation of f of x to the power of g of x. It is not same. Okay, so whenever you see f of x to the power of g of x, you actually do take logarithm and do it. Okay, so y equal to log of x to the power of cos x. So log of y equal to cos x into log x. Okay, so now differentiate on both sides, you will get 1 by y dy by dx equal to, okay, ln of ln x as is, then differentiation of cos x, which is minus sin x, then cos x as is, and then differentiation of ln minus x. Okay, so you expand it. This is minus sin x into ln of ln x, okay, log x, plus cos of 1 by x into 1 by log x. Okay, now you put up, I mean, adjust the terms correctly. This is what the answer is. Okay, next, x to the power of x minus 2 to the power of sin x. Okay, now this is another problem which is very important. How to do? If you take logarithm on both sides, then you cannot do any separation, right? It will just become log of x to the power of x minus 2 to the power of sin x. That's it. You cannot make it into some or difference, right? So in such cases, consider each term as a function. Okay, so I will consider this as g of x, this is some h of x, then take separate differentiation, and we know differentiation of two functions in subtraction is same as differentiation of them individually, correct? du plus or minus v differentiation is differentiation of u plus or minus differentiation of v. So same way we'll do. You take, okay, this is the given function y equal to, then I will consider u as x to the power of x and v as 2 to the power of sin x. Now individually I will differentiate. Okay, ln of u is nothing but x log of x, which means 1 by u du by dx equal to x by x plus log of x, which means du by dx is nothing but x to the power of x into 1 plus log x. Now, v is 2 to the power of sin x, so log of v equal to sin x into log of 2. Okay, which means 1 by v dv by dx equal to log 2 into cos x. Okay, so dv by dx equal to log 2 into 2 to the power of sin x into cos x. Now dy by dx is nothing but du by dx minus dv by dx. So this is the answer. So this is the important way of doing this, solving this such problems. Okay, wherever you have power and the terms are in addition or subtraction, or even in that case multiplication also, you can actually solve it this way. This is the easier way. Okay, next. Yeah, same thing. You have three terms in power. You can apply differentiation of UVW or take a logarithm. Then all the product terms will become addition. So it is easy. Okay. So if I take logarithm, log y equal to log of all these values, which is nothing but log of individual sum of logs of individual terms, which is log of x plus 3 whole square, log of x plus 4 whole cube plus log of x plus 5 whole to the power of 5. So this is nothing but 2 into log of x plus 3, 3 into log of x plus 4 plus 4 into log of x plus 5. Now if I differentiate, it is very easy. So this is the answer. Okay, next. Yeah, here also you have to take two terms separately and then logarithm of individual terms. Okay, so this is my u is nothing but x plus 1 by x whole to the power of x. So log of u equal to x times log of 1 plus x 1 plus 1 by x. So 1 by u du by dx equal to log of x plus 1 by x plus, okay, uv rule I am applying, plus x by x plus 1 by x into derivation of x plus 1 by x, which is nothing but 1 minus 1 by x square. Okay, so now you just simplify, du by dx is nothing but x plus 1 by x whole to the power of x into log of x plus 1 by x plus x square minus 1 divided by x square plus 1. Okay, so now similarly v you take, v is nothing but x to the power of 1 plus 1 by x, which is log v equal to x plus 1 by x log of x. So differentiate on both sides, and then dy by dx is nothing but du by dx plus dv by dx. So sum both of them and simplify. This is the answer. Okay, yeah, next. dy by dx equal to log x to the power of log x whole to the power of x plus x to the power of log x. Okay, you take again two separate terms u and v, apply logarithm and solve it. You will get the answer. Okay, this is the answer here. Okay, procedure is exactly same. Just don't do mistake. Okay, do it yourself first and then cross check the answer here. Answer and method. Okay, dy by dx, again you have sin x whole to the power of x, so you have to consider this as u and then take log u and solve it. Sin inverse of square root of x is simple. This is 1 by square root of 1 minus x into differentiation of square root of x. Okay, so this is simple. You can solve it yourself. Next, dy by dx equal to x to the power of sin x plus sin x to the sin x whole to the power of cos x. Again, you will consider u as x to the power of sin x, v as sin x to the power of cos x. Then solve the same using logarithm. Okay, so this is the answer here. You can cross check your answer. Next, okay, dy by dx of x to the power of x cos x plus x square plus 1 by x square minus 1. Okay, same thing. You will take u and v. Okay, then you take logarithm, solve du by dx and dv by dx, and then sum of those two. So this is the method is same exactly. Okay, this is where it is solved. Differentiation of x cos x whole to the power of x plus x sin x whole to the power of 1 by x. So you will do same way. You assume this is the first term is u, second term is v, and then take logarithm on both sides. Okay, so by taking logarithm, you can easily solve this differentiation. Okay, so u equal to x cos x whole to the power of x, then log u equal to x into x times log x cos x, which is nothing but x log x plus x log cos x. You can do this way. Okay, so now differentiation of this one on both sides, you will apply uv on each of them. Okay, a differentiation of uv on each of them. So this is what you will get. One is x by x, which is 1 plus log x, okay, plus x, if I differentiate x, then log of x cos x minus x times 1 by cos x into cos x differentiation, which is sin x here. Okay, so this is how you will do. So you got your du by dx, and then you assume v equal to x sin x whole to the power of 1 by x. Same way you will do. This is your dv by dx. So dy by dx is nothing but addition of these two. So this is the simplification of that. Okay, so such a big expression is your answer. Okay, just keep trying. Actually, you have to keep doing this such tough problems. Only then you will understand it very detailed how to do differentiation using chain method and then other trigonometric and all operations. Okay, next. Yeah, this is very simple. X to the power of y plus y to the power of x equal to 1. You take each term as u and v and then do it same way. Okay, take logarithm on both sides, then differentiate. Okay, so that way you will get the answer. Okay, same way, exactly same one. Just it is minus, that's all. Okay, so you can take differentiation on both sides directly. Okay, so it will become y log x equal to x log y. So dy by dx into log x plus y by x equal to, okay, log y plus x by y into dy by dx. Okay, now you take all dy by dx terms one side. So I'll have log x minus x by y into dy by dx equal to log y minus y by x. So my dy by dx is nothing but y times x log y minus y divided by x times y log x minus x. Okay, next. This is also similar to that. You have xy here. So if you take log on both sides, okay, log xy, you can write it as log x plus log y, then which is equal to x minus y log e, which is 1. Okay, now this is very simple. So you can get dy by dx as x minus 1 into y divided by x times 1 plus y. Okay, next, f of x equal to 1 plus x plus 1 plus x square plus 1 plus x power 4, 1 plus x power 8. Okay, find f dash of 1. Okay, at a given value. Okay, so first thing is you can take logarithm. Okay, then this product will become multiplication. Sorry, product will become addition of logarithms, individual logarithms. Correct. So log of f of x equal to log of 1 plus x plus log of 1 plus x square and so on. Okay, so if I do differentiation of this one, this is 1 by f of f dash of x divided by f of x equal to 1 by 1 plus x, 1 by 1 plus x square and x square differentiation 2x, and similarly 1 by 1 plus x to the power of 8, x to the power of 8 differentiation 8 times x to the power of 7 here. Okay, so this is your expression. Now your f of x is this whole thing. Now I need to find out f dash x at 1, x equal to 1. So if I substitute 1, what I will get is 2 to the power of 4 into 1 by 2 plus 2 by 2 plus 4 by 2 plus 8 by 2, which is 120. That's the answer. Okay, next. Okay, differentiate this expression in three ways mentioned below. One, by using product rule. by expanding the product to obtain the single polynomial, then by logarithm. Okay, let's do one by one. First product rule, UV rule. We know UV rule, U dash V plus UV dash, correct? So f of x is product of these two terms. So differentiation of first one is nothing but 2x minus 5, okay, into x cube plus 7x plus 9 plus x square minus 5x plus 8 into differentiation of second term, which is 3x square plus 7. Okay, so this is your df by dx. Okay, now you can multiply them and simplify it. What you will get is 5x to the power of 4 minus 20x cube plus 45x square minus 52x plus 11. This is your df by dx. Now second method I will do it here. Okay, second method is, first I will multiply these two. So if I multiply these two, f of x is nothing but x to the power of 5 minus 5x power 4 plus 15x cube minus 26x square plus 11x plus 72. Okay, now df by dx is, if you see this one here, it is same as first method. Okay, so both methods we got same answer. Now let's do the third method. Okay, third method is, I'll take logarithm on both sides. So log of f of x equal to log of these two in addition, correct? Log of x square minus 5x plus 8 plus log of x cube plus 7x plus 9. Now f dash x by f of x, this is, okay, which is equal to, okay, 1 by this expression, then differentiation of this one, which is 2x minus 5, plus 1 by this value, then differentiation of this one, 3x square plus 7. Now if I take fx to the other side, which is product of these two, what I am left with is exactly same as what first method. Okay, because product is here, it will cancel the one term and then you will have the other term. So 2x minus 5 into x cube plus 7x plus 9 plus 3x square plus 7 into x square minus 5x plus 8. Okay, now if you simplify, you will obviously get same thing, because first method also we got this one, right? Okay, so all three methods differentiation is same. This is the conclusion. Okay, so you can do differentiation in many methods. Okay, you choose your method which you are comfortable at and which you don't do mistakes. Okay, next. Okay, uv and w are functions of x, then show that differentiation of uvw with respect to x is equal to this value. Okay, this is what I was telling in the first problem in this exercise. Okay, that we will prove this formula, right? So this we can prove it in two methods. We'll do it here. Okay, first method is here. Okay, I will treat the differentiation of uvw, I will treat uv as one function. Okay, then it will become differentiation of uv into w. This is nothing but differentiation of uv into w plus uv into differentiation of w dw by dx, correct? Now differentiation of this one I can again do, right? If I expand it, du by dx into vw plus dv by dx into uw plus uv into dw by dx. Now if you put this one, this is the one, exactly this is one I was showing in the first question. U dash vw plus u v dash w plus u v w dash. Okay, if you take logarithm also, you'll get same log. If I take both sides, I'll get a log of u v w, okay, which is equal to log u plus log v plus log w. So this one differentiation is nothing but 1 by u v w into differentiation of u v w by with respect to x here, then 1 by u plus du by dx plus 1 by v into dv by dx plus 1 by w into dw by dx. Okay, this is nothing but what we are seeing here, right? Exactly same. Okay, so both methods will prove the same differentiation, and you can use this one, this formula, you can use it to solve many problems. Okay, next, let us understand the differentiation of parametric form. Okay, so first let's understand what is parametric form. So far we have seen x is defined in terms of y, or y is defined in terms of x, or mix of it, correct? That is explicit form and implicit form. Now parametric form is both x and y are defined in terms of some other third variable, let's say t or theta. Okay, then what happens? Okay, so x equal to f of t, y equal to g of t, then dy by dx is nothing but, first differentiate y with respect to t, so you will get your dy by dt, differentiate x with respect to t, which you will get dx by dt, then divide both of them, dy by dt divided by dx by dt, you will get your dy by dx. Okay, so this is looks very simple, but it is a powerful tool to solve many problems actually. Okay, so let's see some simple example first. Okay, let's say y equal to a cos theta and x equal to b sin theta. So dy by d theta is nothing but minus a sin theta. I am differentiating y with respect to theta. Okay, now differentiate x with dx by d theta is nothing but b cos theta. Now my dy by dx is division of these two, right? So minus a sin theta divided by minus b cos theta, which is minus a by b tan theta. Okay, so this is how you will get your differentiation of your in the if functions are defined in parametric form. Okay, let's see another example. Okay, which is like dy by dx. You find dy by dx if x cube x to the power of 2 by 3 plus y to the power of 2 by 3 equal to a to the power of 2 by 3. Okay, if you look at only the problem description, it doesn't look like you use parametric form to solve this problem, correct? You can as well solve it directly differentiating and solve it. Okay, but using parametric form also I can solve it if, let's say, if it is more complex. Okay, this you can solve using normal method, but if it is more complex, you may have to take help of parametric form. How? Let's say let x equal to a cos cube theta, y equal to a sin cube theta. Then what happens? X to the power of 2 by 3 plus y to the power of 2 by 3 is nothing but a cos square theta plus a sin square theta, a square cos square theta plus a square sin square theta. Okay, so which is sin square theta plus cos square theta is equal to 1. Okay, that means you will get a to the power of 2 by 3, which is this expression. So my x and y definitions are good, right? Good to go. Now you solve using parametric form, which is simple. X equal to a cos cube theta. So dx by d theta, sorry, dx by d theta equal to a times 3 cos square theta, and cos definition is minus sin theta, which is nothing but minus 3a cos square theta sin theta. dy by d theta is nothing but 3a sin square theta cos theta. Now dy by dx is nothing but minus tan theta. Okay, which is nothing but, if I take tan theta, how do you get? Sin by cos is tan theta, right? So sin cube by cos cube equal to y by x. That is tan cube theta equal to y by x. Tan theta equal to cube root of y by x. Correct? Tan theta is cube root of or y by x to the power of 1 by 3. That's what I wrote it here. Okay. So hope you understood how to use parametric form. Let's do some problems based on these now. Okay. Exercise 5.6. Very simple. X equal to 2at square, y equal to at to the power of 4. Okay. So you will differentiate individually and then divide. Correct. So dx by dt is 4at, dy by dt is 4at cube. So my dy by dx is nothing but 4at cube by 4at, which is t square, right? And now second one, x equal to a cos theta, y equal to b cos theta, which you can easily do it. Both are cos thetas only. Okay, so dx by d theta is minus a sin theta, dy by d theta is minus b sin theta, dy by dx is minus b sin theta by minus a sin theta, which is nothing but b by a. Okay, so this is also straightforward. You can do it yourself. Only thing is there will be ways to simplify your final answer. Okay, so if I do dy by dx, I am getting actually minus 2 sin 2 theta by cos t, which I can write it as minus 4 sin t cos t by cos t. Okay, right, which is nothing but minus 4 sin t. Okay, more simpler form. It depends on question. What are the, if it is multiple choice, you have to see which option is correct. Okay, so please keep simplifying your final answers. Yeah, next. If x equal to 4t and y equal to 4 by t, again straightforward, you will one dx by dt is 4, straightforward, dy by dt is minus 4 by t square. So you will get answer minus 1 by t square, dy by dx is. Okay, so this is also straightforward, cos theta minus cos 2 theta x, and y is sin theta minus sin 2 theta. So you will straightforward, you will do dx by d theta, dy by d theta, values are there. So okay, you can get dy by dx easily. Okay, now x equal to a times theta minus sin theta, y equal to a times 1 plus cos theta. Okay, which is very similar. Okay, you will individually do dx by d theta and dy by d theta. Then dy by dx you will get, which is nothing but minus cot theta by 2 if you simplify. You can say this is also answer, but if you simplify further, this is what you will get, minus cot theta by 2. Okay, next. Yeah, this is a little bit complex if you see actually x and y, but you will do in the same way. Okay, so only thing is, yeah, it's a doing the differentiation itself is a big task here. Okay, so dx by dt is nothing but, okay, this is in u by v form, correct? So here you will get square root of cos 2t, which is nothing but cos 2t, and here differentiation of sin cube t, which is 3 sin square t into cos t, and product of this one, square root of cos 2t minus sin cube t, I wrote it as is, and then differentiation of this one, which is nothing but 1 by 2 square root of cos 2t, and cos 2t differentiation is minus sin 2t into differentiation of 2t, which is 2. Okay, so now use simplification carefully. Okay, if you simplify, this is what you'll get: sin square t into cos t times 3 cos 2t plus 2 sin square t divided by cos 2t into square root of cos 2t. Okay, similarly you do it for y. This is what you will get: cos square t into sin t into minus 3 cos 2t plus 2 cos square t divided by cos 2t into square root of cos 2t. Okay, now your dy by dx is simplification. Finally you will get minus cot 3t, minus cot 3t. Okay, so do it carefully, that's all. Method is same, exactly same. You are applying your parametric method, your quotient method, then trigonometric differentiation, chain method, all the things you are applying here in this problem. Okay, so do it yourself. This one definitely you should solve it yourself once and cross check your answer. Okay, next. Yeah, x equal to a times cos t plus log of tan t by 2, y equal to a sin t. Okay, so dx by dt equal to, yeah, you have to differentiate this one. So a times minus sin t plus this, you will solve it 1 by tan t by 2 into tan t by 2 differentiation is secant square t by 2, and t by 2 differentiation is 1 by 2. Okay, so this is what your dx by dt. Okay, and your dy by dt is here. Actually I missed it. This is, sorry, this is all dx by dt. If I simplify, you will get a cos square t by sin t. Okay, you simplify this one. Basically that's what I am doing here. Okay, cos 2t and cos square t by 2, cos t by 2 and cos square t by 2, so they gets cancelled, one will be remaining. So this is nothing but 2 sin t by 2 cos t by 2, this is nothing but sin t. So I wrote minus sin t plus sin t. So if I yeah, take LCM and then make it into common LCM, this is what I'll get, which is nothing but this value. Okay, and dy by dt is nothing but a cos t. So my dy by dx is a cos t divided by this value. So I'm just reciprocal, I'm taking, multiplying with reciprocal, sin t by a cos square t. So cos t will get cancelled. I am finally left with a tan t. Okay, so it looks so simple. Final answer, right? dy by dx. Next. Yeah, this is a straightforward question. You can do it yourself. Okay, only thing is simplification is important. You will get finally b by a cosecant theta. Okay, so simplification is important. Yeah, this is again similar to the previous one we saw. Okay, you can do it yourself. Dx by d theta, dy by d theta you take and divide both of them, you will get tan theta. Okay, next. dy by dx equal to minus y by x. Okay, if, okay, we have to show this. Okay, prove basically. X equal to square root of a to the power of sin inverse t, y equal to square root of a to the power of cos inverse t. Best method is you can take actually logarithm and do it. Okay, or differentiation of square root of x and then parametric method you can do. Okay, so this is nothing but, x is nothing but a to the power of sin inverse of t whole to the power of half. Correct. So this I can write it as a to the power of half into sin inverse of t, because this is in the form of a to the power of b to the power of c, so which is nothing but a to the power of bc. Okay, a to the power of b whole to the power of c. Correct. So I can write it like this. Now I can apply my differentiation on a to the power of x. A to the power of fx differentiation is nothing but a to the power of fx log of a into differentiation of f of x. Okay, so this I will apply here. Dx by dt is nothing but a to the power of half sine inverse t log a into differentiation of half sine inverse of t, which is nothing but I wrote it here 1 by 2 times square root of 1 minus t square. Okay, so finally this is what you will get. Your dx by dt is x times log a of log a into 1 by 2 times square root of 1 minus t square. Similarly y is there, and y you will get y into log a into minus 1 by 2 times square root of 1 minus t square. When you divide both of them, dy by dx, what you are left with is minus y by x. Okay, so we proved it. Dy by dx equal to minus y by x. Okay, second order differentiation. Okay, this is the last topic in the differentiation. With this, we'll cover all the ways of differentiation and what we can achieve from differentiation. Okay, so let's understand this one. This is also very simple. Nothing but you do differentiation second time, one more time. Okay, so if f of x is a function, f dash x is called first differentiation. Then f double dash x which is nothing but df dash x by dx is called second order differentiation. Okay, it is denoted by many ways, f double dash x or d square y by dx square or d2 y double dash or y2. Okay, so these are the ways you can denote them. Let's do some simple example here. Okay, if y equal to, okay, this is the definition which I just now explained actually. Y equal to f of x, first differentiation is y dash, second differentiation is y double dash. Okay, now let y equal to 3x to the power of 6 plus 4x square plus 3x plus 9, then y dash is nothing but 18 times x to the power of 5 plus 8 times x plus 3. Okay, now y double dash, which is nothing but second order differentiation, is 90x to the power of 4 plus 8. Okay, now another example, let f of x equal to sin x, then f dash x is cos x, f double dash x equal to minus sin x, which is nothing but minus f of x. Correct? So these are the ways, this is the way you do differentiation. Let's do some exercise and understand some problems. Okay, second order differentiation exercise we need not do, I need not explain much because you know how to do differentiation. So once you get the first differentiation result, just apply one more time, that's all you have to do. Okay, so let's do exercise 5.7. Okay, the second order derivatives of x square plus 3x plus 2, it is the absolute straightforward. Correct, f of x is x square plus 3x plus 2, f dash x is 2x plus 3, f double dash x is 2. Similarly, you can do for x to the power of 20, you can do it yourself. Okay, yeah, this is 380 x to the power of 18. Okay, next, uh, of x cos x. So x cos x, first differentiation is nothing but cos x minus x sin x. You will apply UV rule here. Then second order differentiation, for cos x it is minus sin x, and for x sin x you again apply UV formula. So you will get sin x plus x cos x. Okay, so overall it is minus 2 sin x minus x cos x. Okay, differentiation derivative of second order derivative of log x is, first f dash x is 1 by x, f double dash x is minus 1 by x square. Okay, next, x cube log x, you will apply UV rule for the obtaining first order and as well as second order differentiation. Okay, so first order differentiation is x square times 3 log x plus 1. Second order differentiation is, you can do it same way, x square 2x and then 3 log x plus 1 plus x square as is, and then 3 log x differentiation is nothing but 3 by x. So overall it is x times 6 log x plus 5. Okay, next, e to the power of x sin 5x. Same way you will do UV rule, you will apply. F double dash x is nothing but e to the power of x into 10 cos 5x minus 24 sin 5x. Okay, next. Yeah, same way you will do. You can just do it yourself and cross check answer. I am skipping most of this because it is just a differentiation. You will do once again, right? So you already done many differentiations. This is same way. You will do 2 times. That's all. Okay, tan inverse of x, f dash x is nothing but 1 by 1 plus x square, then you will do 1 by x differentiation again. So you will get f double dash x is nothing but minus 2x by 1 plus x square whole square. Okay, log of log x, you will do same way. Okay, sine of log x, you will do same way. Okay, then there are some interesting problems here, yeah, to prove. Okay, so it is mentioned that y equal to 5 cos x minus 3 sin x, prove that y double dash plus y equal to 0. Okay, so this is simple. First is find out what is y double dash. Correct, so y is this one, y dash is minus sin x minus 3 cos x, y double dash is minus 5 cos x plus 3 sin x, which is nothing but, if I take minus common, it is nothing but 3 cos x minus 3 sin x, which is same as y, so it is minus y. Y double dash is minus y, so y double dash plus y equal to 0. Correct, next, if y equal to cos inverse of x, then find d square y by dx square in terms of y alone. Okay, in terms of y alone, that is important. Okay, so y is cos inverse of x, x equal to cos y then. Correct, x equal to cos y. Now differentiate. So dy by dx is nothing but minus 1 by square root of 1 minus x square. Okay, now x is cos square, cos y, we know it, so it will become, this will become minus 1 by square root of 1 minus cos square y, which is nothing but sin y. So minus 1 by sin y, which is equal to minus cosecant y. You can also differentiate here, you will get same directly. Dx by dx is 1. equal to minus sin y dy by dx. So dy by dx is nothing but minus cosecant y. Same thing you will get from here. Okay. So second order differentiation, simple. D square y by dx square is nothing but minus cosecant y into cot y into dy by dx. Okay. Dy by dx is nothing but, we know, minus cosecant y. Okay. Don't forget this value. Okay. You are differentiating with respect to x. So you will have a dy by dx extra here. It is not that you are not doing dy by dy. Okay, this cosecant y differentiation with respect to y. You are not doing that. You are doing with respect to x. So you will get a dy by dx. Okay, so this is d square y by dx square is nothing but minus cosecant square y into cot y. Okay, you get one extra here. Okay, yeah. Next, y equal to 3 cos log x plus 3 sin log x. Show that x square into y2 plus x y1 plus y equal to 0. Okay, yeah, this is an interesting one. See, this is given y. So y dash first, y dash is nothing but y1. This is the other way of representing, I mentioned. Minus 3 sin log x, minus 3 sin log x, and log x differentiation is, again, we will do it here 1 by x. Okay, plus 4 cos x, 4 cos of log x, and log x differentiation is 1 by x. Okay, so if I take x to the other side, it will become x y1 equal to minus 3 sin of log x plus 4 cos of log x. Okay, now I am differentiating this one. Okay, this is in UV form. So 1 into y1, x differentiation is 1, y1 plus x is as is, and then y1 differentiation is y2, which is equal to minus 3 cos of log x into 1 by x log differentiation, then minus 4 sin of log x into 1 by x log differentiation. So this is nothing but minus y by x. Okay, now you take x to the other side, it will become x square y2 plus x y1 equal to minus 5, or x square y2 plus x y1 plus y equal to 0. Okay, this is what we are trying to show. This is, we got it. Okay, so hence proved. Next, y equal to a to the power of a into e to the power of mx plus b into e to the power of nx. Show that y double dash minus m plus n y dash plus mn y equal to 0. Yeah, this is also straightforward. You first get y dash. Y dash is nothing but this value, a m e to the power of mx plus b n e to the power of nx. Y double dash is y m square e to the power of mx plus b n square e to the power of nx. Now m plus n into y1, y dash, which is nothing but m plus n into this value. You expand it, m into this, m into second term, n into first term, n into second term. Okay, these are the 4 terms you got. Now carefully check. Okay, m plus n y dash equal to, you will get this value, correct? Y double dash plus you are left with mn, if I take common, a e to the power of mx plus b e to the power of nx, which is nothing but my y, correct? So m plus 1 y dash equal to y double dash plus mn into y. Okay, so if I rearrange it, you will get y double dash minus m plus n y dash plus mn y equal to 0. Okay, so hence proved. Y equal to 500 e to the power of 7x plus 600 e to the power of minus 7x. Then show this one. This is the second order derivation, very simple actually, because e to the power of x always you will get same value, right? Only thing is it is e to the power of 7x, so 7 multiplication will come always extra, correct? So first differentiation I get 7 multiplication minus 7 multiplication. Okay, second order derivation I get 7 square here multiplication and minus 7 square, which is same, right? Minus 7 square is same as 7 square. So 49 I can take common and I am left with the same expression, which is y. Okay, so d square y by dx square is 49y. Okay, next. E to the power of y into x plus 1 equal to 1. Show that d square y by dx square equal to dy by dx whole square. It is simple. First, find out y dash and y double dash, then you can easily conclude this. Okay, so my y dash is nothing but dy by dx is minus 1 by x plus 1 whole square. D square by dx square is nothing but 1 by x plus 1 whole square. So d square y by dx square is equal to dy by dx whole square. Right? Next. Y equal to tan inverse of x whole square. Show that x plus 1 square whole square y2 plus 2x times x square plus 1 into y1 equal to 2. Okay, so first thing is, yeah, you need y1 and y2, right? Y dash and y double dash. So y dash is nothing but y1, that is y1 is nothing but 2 times tan inverse of x and differentiation of tan inverse of x, which is nothing but 1 by 1 plus x square. So this is my y dash. Okay, if I take 1 plus x square to the other side, it will become 1 plus x square into y1. Okay, equal to 2 tan inverse of x. Okay, now differentiate on both sides. This will become 2x into y1 plus 1 plus x square into y2, because this is in UV form, equal to 2 by 1 plus x square. Now if I take 1 plus x square to the other side, this is what I get. 1 plus x square whole square into y2 plus 2x into 1 plus x square into y1 equal to 2. This is what we are trying to prove. So hence proved. Okay. Let's do the last section, which is miscellaneous exercise. I think at least half of them will be easy one, which we have done many ways. Okay, so let's go quickly through the easier ones and then do the harder ones, tougher ones. Okay. Yeah, I think this you can do differentiation with of f of x, which is a simple polynomial to the power of some 9, right? So you can do it yourself. Second one also, it is just a trigonometric trigonometric equation, sine cube x plus cos to the power of 6x. You can do it yourself. Okay. Most important thing is the final answer. If you simplify, it is better. Okay. The differentiation of 5x to the power of 3 times cos 2x, which you have to use logarithm, because it is f of x to the power of g of x. So use logarithm to solve this one. Okay. Next. Yeah, sine inverse of x square root of x. So you will use uh, implicit or chain rule basically. Okay, and the trigonometric inverse differentiation, right? Sine inverse is nothing but 1 by square root of 1 minus x square root of x whole square. Okay, now x square root of x differentiation is 3 by 2 into x to the power of half. So you simplify it, this is the answer you will get. 3 times square root of x divided by 2 times square root of 1 minus x cube. Okay. Next, f of x equal to cos inverse x by 2 divided by square root of 2x plus 7. So you will apply the u by v, right? Quotient rule, differentiation by quotient rule. So you will get the answer. Okay. The denominator is squared, so 2x plus 7, and then individually uh, u dash v minus u v dash. This is what you did. Then you will get the answer. Okay. Now this one is, yeah, you look at this one, cot inverse of the big expression. So you can apply directly trigonometric inverse of cot inverse and then do it, but let's look at carefully. You have 1 plus sin x, square root of 1 plus sin x, and square root of 1 minus sin x common, right? So something should strike you. Sin x you can write it as 2 times sin x by 2 cos x by 2. 1 you can write it as sin square x by 2 plus cos square x by 2. Then it is in the form of a plus b whole square. Okay, so I can remove the squares. So you look at this one. 1 plus square root of 1 plus sin x, I will write it as square root of sin square x by 2 plus cos square x by 2 plus 2 times sin x by 2 cos x by 2, which is nothing but square root of sin x by 2 plus cos x by 2 whole square, that is cos x by 2 plus sin x by 2. Similarly, square root of 1 minus sin x, I will write it as cos x by 2 minus sin x by 2. So my whole expression is simply cot inverse of cot x by 2, which is nothing but x by 2. My whole expression is just f of x is nothing but x by 2. Okay, so f dash x is 1 by 2. Okay, so you need to apply your trigonometric and other functional knowledge to solve the differentiation easily. Okay, f of x equal to log x to the power of log x. So definitely this is in the form of f of x to the power of g of x. So you will use logarithm. Okay, so apply logarithm on both sides and then differentiate. Okay. Now cos of a times cos x plus b times sin x. Okay, you will apply parametric. Okay, or chain rule basically. You can apply chain rule to solve this one. Okay, so f of x equal to cos. So cos differentiation is minus sin a times cos x plus b sin x, and differentiation of this a cos x plus b sin x, which is nothing but this minus a sin x plus b cos x. Okay, next. Okay, sin x minus cos x whole to the power of sin x minus cos x. You will use logarithm here. Okay, because it is in the form of y to the power of y, right? Okay, or I can say this is y. So dy by dx is nothing but cos x minus sin x. Okay, so f of x equal to y to the power of y. So logarithm I am taking and then I am solving. Dy by dx is nothing but this value. So I'll substitute it here. Okay. f of x equal to x to the power of x plus x to the power of n plus a to the power of x plus a to the power of n. Okay, so this is the constant. It will become 0 if I differentiate, so ignore it. Okay, then x to the power of n differentiation is n into x to the power of n minus 1. So these two terms I will take logarithm and solve them first and then add them separately. Okay, so my u is x to the power of x, v is a to the power of x. So if I differentiate, I will get du by dx is x to the power of x into 1 plus log x, and dv by dx is a to the power of x into log a. Then I will f of x, f dash x, I will sum up all this. Okay, so this is my answer. Okay, x to the power of x square minus 3 plus x minus 3 whole to the power of x square. Again, you will take logarithm, you will say uv and then take logarithm of du by dx and dv by dx and then add both of them. Okay, so my u is first term, v is second term. Take logarithm, differentiate and then add final answer f dash x equal to du by dx plus dv by dx. Okay, y equal to 12 times 1 minus cos t and x equal to uh, 10 times t minus sin t. This is parametric method, correct? So you will say dy by dt, dx by dt, and then you will get dx by dt as division of both of them. Divide both of them, you will get dy by dx. Okay. So this is also simple. Final answer is, if you simplify, you'll get 6 by 5 cot t by 2. Okay. Simplification is very important, as I am telling every time. Okay, y equal to sin inverse x plus sin inverse of square root of 1 minus x square. You can easily do inverse trigonometric differentiation and parameter and chain method here. Okay, you will get the answer. X times square root of 1 plus y times square root of 1 plus x equal to 0. Okay, x is between minus 1 to 1. Prove that dy by dx equal to minus 1 by 1 plus x whole square. Basically, find out what is dy by dx. Okay, so you can actually directly take this expression and differentiate. Okay, it is possible, but you have square roots and then 1 plus 5, all this, right? So instead of that, you can just square it because other side is 0. If you take this one term to other side and square it, you get a simple equation without squares, correct? So that is nothing but x square into 1 plus y equal to y square into 1 plus x. Okay, then you simplify it further, x square plus x square y equal to y square plus y square y. I can take few things, x square minus y square equal to y square x minus x square y. I can cancel something and then simplify this equation. This is nothing but y equal to minus x by 1 plus x. Okay, now this is simple, very very simple. Dy by dx is nothing but, okay, u by v rule, minus is here, then divided by denominator will become 1 plus x whole square, then differentiation of x into 1 plus x minus x into differentiation of 1 plus x, which is 1. Okay, so this is nothing but minus 1 by 1 plus x whole square. This is what we're trying to prove it. So each question you have to find out, okay, whether you want to use your number theory, your algebra, your trigonometry, your whatever information already you know, you can use it to simplify the equation so that your differentiation is easy. Okay. Yeah. Next, x minus a whole square plus y minus b whole square equal to c square. For some c greater than 0, prove that this value. Okay. So this is also same. You need dy by dx and d square y by dx square, right? To second order differentiation also you require. Okay. So you take it and differentiate directly. What you will get is 2 times x minus a plus 2 times y minus b into dy by dx equal to 0. So dy by dx is nothing but minus x by x minus a by y by b. Okay. This is one equation which you have already. Okay. You found out this one. Now second order derivative, which is d square y by dx square, is nothing but y minus b whole square. Okay, differentiation of x minus a is 1, so y minus b minus x minus a into dy by dx. Okay, and dy by dx, I'm substituting this value again. Okay, so and simplify it, what you will get is d square y by dx square is nothing but minus c square by y minus b whole cube. Okay, now take the given expression. Okay, and directly substitute. You have both the values, dy by dx you have, d square y by dx square you have. Substitute it and see. Okay, simplify it, what you will get is this is equal to minus c. This is what you will get. Okay, so if it is minus c, that means the given expression does not depend on a and b. That is what is asking us to prove, right? This expression is independent of a and b. This expression is equal to minus c. That's what we got. So it is independent of a and b. Okay, next. Cos y equal to x cos a plus y. Okay, where cos a is not equal to 1. Prove that dy by dx equal to cos square a plus y by sin a. Okay, so this one is another tricky one. You will basically do it in a reverse way. Okay, reverse means you find out dx by dy, it is more easy. Okay, so let's see how to do this. Cos y equal to x times cos a plus y. So x is equal to cos y by cos a plus y. Now x is defined in terms of y. Very simple way, correct? So now you do dx by dy. Dx by dy is nothing but minus sin y into cos a plus y minus cos y into minus sin of a plus y divided by cos square a plus y. Okay, now you take this one and simplify it. Okay, so what you will get is sin a plus y minus a, because this is nothing but sin a cos b minus sin b cos a. So this is nothing but sin a minus b. So sin a plus y minus y by cos square a plus y. So dx by dy is nothing but this value sin a by cos square a plus y. So dy by dx is reciprocal, which is cos square a plus y by sin a. Okay. So this is another way of solving problems. So careful which one chooses the problem, you have to decide. Okay. This comes by two ways: practice, one thing important, and the second one is you should know all the formulae of the algebra, trigonometry, all these things you should know, so that you can apply them appropriately. Okay. Next, x equal to a times cos t plus t. Okay, this is parametric form. So you just need to find the second order derivative in the parametric form. That's all. Okay, so you take first dy by dx. Okay, dy by dx is nothing but minus tan t. Okay, but we need to find out d square y by dx square, which I did not do here. You can easily do d square y by dx square is second derivation, right? Again, if you call this one as second order, if I do, I will get, I have to just differentiate this one. Okay, so you can do this. Okay, I just did only first level. Okay, you can do it second level, next level, second order derivative, you can do it. Next, f of x equal to modulus x cube. Show that f double dash x exists for all real x and find it. What is it? Okay, so let's see. F of x is nothing but x cube if x is greater than 0. It is minus x cube if x is less than 0. Correct? This is the definition of modulus of x whole cube. Correct? Now, if f dash x exists, if f dash x will be something like 3x square. Okay, if I am differentiating this one for x greater than 0, minus 3x square if x is less than 0. Okay, now if f double dash x exists, it will be 6x if x is greater than 0, minus 6x if x is less than 0. Okay, now from the definition of f of x and f dash x, they are individually continuous and differentiable. Correct? This is individually continuous and differentiable. Okay, same thing here, same thing here, same thing. Same thing here. Okay, individually they are continuous and differentiable. Only thing is we need to check if they are continuous and differentiable at the junction, that critical point, which is x equal to 0. Correct, that is the only thing we need to check. Okay, the point of contention is at x equal to 0. So let's check limit continuity at x equal to 0 first. Okay, so limit of LHL, I think this is RHL, this is LHL actually. So let's call RHL is nothing but limit x tends to 0 plus x cube, which is nothing but 0. RHL also limit x tends to 0 minus x cube, this is also 0. F of 0 is 0. So f of x is continuous at x equal to 0. Okay, and rest all. Correct, rest all is anyway continuous. We know at x equal to 0 also it is continuous. Now differentiability. Okay, LHD is nothing but limit x tends to 0 minus f of x minus f of 0 minus divided by x minus 0 minus, which is nothing but minus x square. Okay, which is 0. At x equal to 0, this is 0. RHD, right hand derivation, also you will get x square, which is nothing but 0. Okay, so LHD equal to RHD equal to f dash 0, which is 0. Okay, so it is continuous at it is differentiable at f dash 0 also. Now check the differentiability at x equal to 0 for f dash x. Okay, because we need f double dash, right? So which is same way I will do limit x tends to 0 minus f dash x minus f dash 0 minus divided by x minus 0. Okay, this is nothing but minus 3x square. Okay, f dash 0 is 0, we know. So minus of 3x square by x, which is minus of minus 3x. Sorry, this is not minus of, this is just 3x actually. Okay, minus 3x, which is equal to 0. RHD also similarly you can find out is 3x, which is 0. Okay, so overall we have proved the point of contention, which is x equal to 0. At x equal to 0, it is continuous as well as differentiable first time and differentiable second time also. Correct? So which means f of f double dash x equal to 6x if x is greater than 0, f double dash x equal to minus 6x if x is less than 0. Okay, and yeah, it is differentiable. Next, using mathematical induction, prove that differentiation of x to the power of n by differentiation of x to the power of n with respect to dx is n into x to the power of n minus 1. Yeah, this is very simple one. So let's call the function f of n equal to differentiation of x power n with respect to dx. This is nothing but n into x to the power of n minus 1. We need to prove this one. Okay. So first, mathematical induction is for positive integer values. So first you start with n equal to 1. For if n is equal to 1, LHS is nothing but dx by dx, because x to the power of 1, which is x, correct? Which is 1. RHS is 1, n equal to 1. So 1 into x to the power of 0, which is 1. Okay, so f of 1 is equal to 1. Now let us assume f of k is true for some integer k. Okay, so f of k equal to differentiation of x power k with respect to dx equal to k times x to the power of k minus 1. Now for n equal to k plus 1. Okay, LHS is nothing but differentiation of x to the power of k plus 1, which is nothing but x to the power of k into x. So I will apply uv formula, u into v. So x to the power of k plus x times k x to the power of k minus 1. So if I multiply this, I will get k plus 1 into x to the power of k. Okay, and RHS is straightforward, because n equal to k plus 1. If I substitute, it will become k plus 1 into x to the power of k. So LHS equal to RHS. So hence we can say, by principle of mathematical induction, it's true for all positive integers. Okay, next. Okay, using the fact that sin a plus b and differentiation, obtain the sum formula for cosines. Okay, so let's do it. Sin of a plus b is nothing but sin a cos b plus cos a sin b. Assume a and b are functions of x. Okay, now differentiate both sides. So this will become cos a plus b into differentiation of a plus b by dx. This will become differentiation of sin a cos b by dx with respect to x, and next one. Okay, so apply uv rule here. You will get this value, cos a cos b dA by dx minus sin a sin b dB by dx minus sin a sin b dA by dx plus cos a cos b dB by dx. Okay, capital B. Okay, so now if I take this common, cos of a plus b equal to dA by dx plus dB by dx, which is equal to cos a cos b into dA by dx plus dB by dx minus sin a sin b and product of this one. Okay, so if I take a common and cancel dA by dx plus dB by dx on both sides, I am left with cos of a plus b equal to cos a into cos b minus sin a into sin b. This is what is the definition of cos a plus b, correct, in trigonometry. So hence proved. Next. Okay, does there exist a function which is continuous everywhere but not differentiable at exactly 2 points? Okay, which means if you draw a graph, okay, you have one straight line, and then it is basically making spikes at two places, correct? Right, so let's take help of a graph and then derive the equation. So this is normally a straight line, so I choose 2 points a and b and make spikes at two places. How can I make? I just bent it like this. So I got a sharp edge here, sharp edge here, and I know that at sharp edges are not differentiable. So this graph, whatever is the equation of this one, this is not differentiable at the point A and point B. Okay, correct. So now let's find what is the equation of this one. So this is simple. You draw a line like a V. Now you know this. What is this equation of this one? This is nothing but modulus of x minus A. This is modulus of x minus B. Correct. Now if your y is equal to modulus of x minus a, and second one is y equal to modulus of x minus b. So my final equation is y equal to x minus a plus x minus b. If I do, then between a and b it will be straight line. Okay, then you will have like this. So it makes two sharp edges, so that at a and b it is not differentiable. Correct. Let's take a and b as 1 and 2. Okay, so it will become y is equal to modulus of x minus 1 plus modulus of x minus 2. This function is continuous for all real numbers, but not differentiable at 2 points, that is x equal to 1 comma 2. Okay, so if I write this one in the definition form, y equal to For x less than 1, both are negative. So it will become 1 minus x plus 2 minus x, which is 3 minus 2x. Okay. If it is between 1 and 2, it will become between 1 and 2, right? So this is positive x minus 1 plus minus x plus 2. So this will be 1. Okay. And if x is greater than 2, it will become 2x minus 3. This function is not differentiable only at 1 comma 2. If you can easily prove that, right? For y equal to 1 minus, correct? This is continuous but not differentiable. That's all. Okay. So you can easily prove that this is not. If I differentiate this one, this is nothing but minus 2, 1, 2. Correct? Minus 2, 1, and 2. So this is not differentiable at 1 and 2. Okay. So this is how you will form your given equation. This is a very interesting question. Just to understand the basics of differentiation, this is how you can do. Okay, next. Yeah, this is in the matrix form. Very simple. You just take the determinant and you can easily differentiate and prove it. Okay, you can do it yourself. Okay, so this is not complex. Very easy. Okay, y equal to e to the power of a cos inverse x. Then show that this value. Okay, so similar problems we have solved. Okay, you can do it yourself. Y equal to e to the power of this one, dy by dx is nothing but e to the power of a cos inverse x and differentiation of a cos inverse x, which is nothing but minus a divided by square root of 1 minus x square. Okay. So this is nothing but minus a by, this is all y, same as y, minus a by divided by square root of 1 minus x square. Okay. I am taking this denominator to the other side. Okay. And differentiating it again. So I'll get this expression. Okay. Now I have my d square y by dx square. Okay. I have my dy by dx term. Okay. Then if I take both of them to the same side, okay, and multiply with, right, minus a times square root of 1 minus x square plus x. Okay, if I take this, correct, if I simplify this one, this fraction, okay, equal to 1 minus x square into d square y by dx square. Okay, then I separated the terms here like this. Okay, then basically I am trying to get into this form. I need basically 1 minus x square into d square y by dx square, which I got. Okay, now I have my x times dy by dx, which I got, and this expression. This is nothing but if I cancel this square root of 1 minus x square on numerator and denominator, I am left with a square y. Correct? So minus a square y. So this is the expression which we are looking. 1 minus x square into second derivative minus x times first derivation minus a square y equal to 0. Okay. You can do it yourself and then look at how I have done it. Okay. Next. Yeah, that's all. So these are all the problems of the differentiation and the differentiability, and you have learned all the tricks of differentiation now. Okay, everything is covered. Only chapter left on differentiation is applications of differentiation, where you can use in a general problem. So that video I will do it next actually, so that differentiation will be complete. Okay, so keep doing maths, and the differentiation is and the limits are one chapter which you need to practice a lot actually, lots of problems. You can watch my videos and as well as my shorts on limits and derivatives. Okay, thank you.